Okay, let's try on a different kind of problem this time. This time we're talking about a wire. What's this wire doing? This wire is going to be extending. Is it magical? No, we're just heating it up. And anything that you heat up, most things that you heat up will expand. And technically they're expanding in all directions, but in this case, all we're going to care about is how much longer it gets. So we have an aluminum wire. Why aluminum? Why not? It is 10 meters long. Initially, that is. And I am going to cool it from 38 degrees Celsius to negative 1 degree Celsius. So starting warm and then going cold. So since it's cooling down, well, it's going to get smaller. And we want to figure out what is going to be the change in length. Now to do this is not that hard. If you think change in length, you're probably thinking back to our previous chapters where we learned about strain. And strain is part of this. So when you heat something up, it expands. How does it expand? Well, it expands proportional to the amount that you heat it. And that proportion is the thermal coefficient of expansion, which is usually an alpha. In this case, we'll do an L because it's for the length. You could also have an alpha V, which is for volume. So we have our strain right here, and then finally a change in temperature. The coefficient of thermal expansion simply says how much strain you get for a particular change in temperature. We also know that strain is equal to my change in length over my initial length. So if I use these two definitions together, I can figure out how temperature change will lead to a lengthening of that wire. So delta over my initial length is equal to the thermal coefficient of expansion times my change in temperature. And so finally, delta is equal to my initial length, the thermal coefficient of expansion times my change in temperature. As a note, for aluminum, you have to look up what thermal coefficient of expansion is. You don't just calculate it. And that is 23.6 times 10 to the negative 6 per degree Celsius. So I'm going to put this in terms of, we'll put it in terms of meters, I guess, to start, and then we can convert it to something else. It's usually a very small amount that ever expands or contracts. So 10 meters there times 23.6 times 10 to negative 6 per degree Celsius. And it went from 38 to negative 1. Oop. Final minus initial, sorry. Negative 1 minus 38. There you go, degrees Celsius. So when I plug that in, I get a very small amount of meters, 9.2 times 10 to the third meters, which is equal to 9.2 millimeters. And that is smaller, it got smaller by negative 9.2 millimeters. And that's it. It's a very simple problem. It's not a very hard thing to do. The biggest thing is just realizing how you can connect these two equations there. So thanks for listening. I hope this helps you, and I'll see you all next time. Bye-bye.